for an automatic house candle lid that would put candles out after a certain amount of time or if a temperature got too hot. What I'd like to do today is show you this product and how we've implemented different circuits and designs and came up with a product that will work in every home. We have our standard size candle here, and I'd like to show you that it's very easy to forget about these things. It's very easy. Say you walk out of the house, you fall asleep, your candle's left burning for hours and hours. In the end, you just end up wasting a candle. There's a statistic that says it only takes 30 minutes for a candle scent to fill a room. There's no need for a candle to burn any longer. Also, if this glass becomes too hot, it will burst, resulting in a dramatic house fire. You could lose everything, all because of a candle. Hey, did you fall asleep while this candle was burning? Don't you know that you could burn down the whole apartment like that? You're crazy. Oh, baby. Here we have our product, who just closed. And I'd like to show you how this is implemented with the candle. Just simply reset, place the candle in the specified hole, and allow the candle machine to do its work. Ethan Parks is the master coder, and he would like to talk to you about what this machine is doing.
Okay, so basically this is our STH11, the temperature sensor, and it's given us three values: a temperature reading in temperature Celsius and in Fahrenheit, also the humidity percent. Once we have the code set up to where once this piece of glass, once it's backed up to the sensor, once it reaches a temperature of over 125 degrees Fahrenheit, then the lid will shut for 15 seconds and put out the flame and then open back up to its original starting position. On average, it's about 150 degrees for glass to break. That's why we have it set at about 125, just for no real room for error and freak accidents. So as you can see, whenever we hold a lighter up to it just for demonstration, let me set it to the side. We will get our temperature readings will increase, as you can tell.
70 to 73, 73 to 88, 88 to 86, a slight drop.
And this temperature sensor is better than your average at home thermostat sensor. It can give you readings of values with 8 decimal places if needed. The accuracy is plus or minus 0.05 degrees off from whatever it actually is.
We're having a little bit of a problem actually getting our sensor hot right now.
It takes a minute.
There we go, 35, 40. And I think the code right now is going to have it close at 55 or 50. And there we have our candle under our lid.
As you can see, it is going out.
And it went out. We're going to talk about the design of it a little bit right now while we have a chance. We have a
Go ahead and unplug it.
large steel plate right here, aluminum checker plate, and a little small piece of angle iron. And our servo is attached right here. We have our arduino, our breadboard, our sensor. And one of the things that was very important is actually this counterweight right here. And that was placed there to help the servo lift that lid. It lessens the moment at the end over here, and it allows for easier and more efficient movements by the servo.
So basically, this is basically what it looks like. We didn't have much time to basically make it look pretty or smaller, or we could even have implemented variable temperatures without having to have a computer, but with the time that we were given and the materials we had, this is basically the best that we could do.